Hello there, my name is Michael McKeever, and my group member that I did this project with was Brian Gillis, and our presentation is going to be over building a geodatabase designed to populations. So, in the first step in designing the geodatabase, before we could even do the geodatabase, we needed to design a schema, which was obtained from exercise 1-1. And all the schema is really just the foundation or the blueprints to your geodatabase. It's designed in Excel. It allows for easy and manipulative reorganization. You can see our layout of our geodatabase. Here we have the type, feature, class name, and alias. So our type for parcels was going to be polygon, and zone boundary is lines. The aliases that will be represented or displayed is land parcels and zoning boundaries. And all of these are just, again, just a blueprints. The scheme is just a blueprints to our geodatabase, and I'll just explain why in depth it is the blueprints. Which leads me to actually creating the geodatabase, which was obtained from exercise 2-1. Our geodatabase was built in ARC Catalog 10.2.1, and like I said, it was based off our blueprints or schema spreadsheet. And the reason for this is because when creating a geodatabase, if you input the data incorrectly, there's no back button. There's no going back to it. That's why this is the tedious part of our project, because if we inputted something incorrectly, it wouldn't have worked. There's no back button, as I already mentioned. So that's what the schema is used for. So we can go back to the schema, manipulate the data, change it with no consequences. But here, once we've already submitted our changes or our data that we inputted, we can't go back in comparison to the schema. Which is why it provides like a nice manageable environment and data sizes and types. It's easy to access and read. That way we can transfer all the data from the schema to the geodatabase, which is why I put it's a semi-permanent environment. And this leads me to our next step, which was actually populating a geodatabase, which would show our results from our geodatabase and what it was going to do. We obtained this from exercise 3-1. So it's a simple data loader, allows for easy data input, populates both spatial and tabular data. All of these are word for word. Adheres to data integrity rules, which were laid down in the first steps. Results in a cartographic output, which you see this map here displayed. You can see the zoning boundaries, the land parcels, which everything was first created in the schema and then transferred into the geodatabase, and now actually can be inputted into a cartographic map, which is seen here in the figure. Matches or transfers data into projections or features data sets. This is an important aspect because everything just already transcribes and transforms into the projection that's wanting to be outputted, which we can see here in the map again. So this was our project, and thank you for your time. If there are any questions, please feel free to ask. Thank you.